This video is going to cover section 1.3, problem solving strategies. In this section, you're going to be given pretty much kind of like riddles, if you think about it in a more friendly way, but just different problems that you want to solve. We're going to be using something called Paulius four-step problem solving strategy. This is a strategy presented by a mathematician named George Paulius, who was born a little over a century ago, 1887 through 1985. He was a professor. I believe he worked at Stanford University, and he published a number of books. But this is the strategy that he said would work with potentially any problem. Okay, and it's pretty self-explanatory. Number one is to understand what you're doing. So understand the problem. Okay. Number two is to devise a plan. So come up with a plan that you think you can use to solve this problem. So kind of like brainstorming, okay? Carry out the plan. So if you think of like a science project, it's the actual the doing of the project where you're trying stuff out and all that. And number four, review the solution. So you want to check your work. Okay, in math we do this all the time. When you solve for x, for example, you can plug the x value back in to make sure that it does in fact come out as a true statement. We're going to go ahead and go right into an example to go ahead and try this out. Here's our example. Determine the digit 51 places to the right of the decimal representing 7 over 27. So let's see if we understand the problem. They want us to find the digit, so the number that's 51 places to the right of the decimal. So this is probably some decimal, so I don't know what it is, but and I'm assuming based that it's 51 places that it's going to go on and on and on and on and on. So I want to know what's the number and the 51th place. So think of it like if you want to think of like sequences, this would be like ace of 1, this is ace of 2, this is ace of 3, and so forth. So we want ace of 51, okay? So even if we were to plug this into a calculator, I believe even our graphing ones would not show 51 numbers. I think it caps it like at 6 or 7. So there has to be some kind of pattern. Okay, so for devising our plan, I think what we should do, and again, this is kind of where you have to be a little bit creative and think about your options. What I think we can do is we can probably, well, first of all, figure out what this decimal is. So we're gonna find the decimal, okay, in this particular example. Okay, so I'm going to have to use a calculator for that. And I'm going to see if I can find a pattern in some of the numbers that it shows. So we're going to look for a pattern, okay? And we're going to use that to see if like maybe the pattern repeats, maybe these are the same numbers over and over. So we're going to check that, okay? So let's go ahead and try that. So number 3 is to carry out the plan. So I'm going to go ahead and plug this into a calculator real quick and just see what it gives me. Give me a few seconds. Okay, so it looks like this number is doing this 259, 259, 25, and it goes on. So I'm going to safely assume that the repeating number here is 259. Okay, so that means that, let me see if I can label this a bit nicer. Ace of 1 is a 2, ace of 2 is a 5, ace of 3 is a 9, and then it repeats. So ace of 4 is a 2 again, ace of 5 is a 5, ace of 6 is a 9, and it just goes on and on and on. So one method that I could probably do, and I'm going to just do this just so you can kind of see a visual, is that we'll put the term here. For terms 1, so let's see, 1, 4, so the fourth term, the seventh term, these are all 2's. Okay, so if you look at this pattern, it's going by 3. So the next one would be, let's see, the 10th term, and so forth. Okay, so it kind of looks like this is going by 3's because, well, there's 3 numbers that are being repeated. Okay, for, let's use a different color. For the next number that repeats, So now we have the second one. We have 2, let's see, 2, 3, 4, 5, and then 8. So again, going by threes, 11. These are all going to be fives. So let me kind of repeat what I'm doing here in case you don't know what I'm writing here. It looks like the term 1 is a 2, term 4 is a 2, term 7 is a 2, term 10 is a 2. So in other words, if I keep going by threes, I'm going to land on a 2 in this sequence, okay? Now, if I start with the second term, those terms are all going to be fives. So here's my second term, here's my fifth term, here's my eighth term. And if you look every three from here, so 1, 1, 2, 3, 1, 2, 3 is going to be a 5. The last one that I have here is that 9. Okay, so the third term, so for term, that looks horrible. You write that nicer. So for the third term, I have that number is a 9. Okay, so we have 3, the sixth term, the ninth term, the 12th term. This is kind of easier because just going by threes, but these are all nines. Okay. All right. So how is that going to help me? Well, if you look at the pattern here, I'm going to scroll up a bit. We could keep going by threes and see which of these is going to land on 51. So we could do that. Let's try that with the first one. So that's going to be, let's see, 13, 16, 19, 22, 25. It's going to keep on going, 28, 31, 34, 37, 40, 43, 46, 49. And I'm out of space, 52. So it's not going to be this one because it's already out of range. Okay. So we can do that again. I'm not gonna, I think I'm gonna stop here though, because I kind of want to show you a shortcut. So this is one method to do it. We can actually go all the way to the pattern and find until we get to 51. But I think what I'm going to do instead is, since I'm seeing that there's a pattern of every three numbers, okay, I'm going to divide 51 by 3 and see what that gives me. And I'm going to actually do this using division the long way, so you can kind of have a better visual. Okay, so 3 into 5 is 1. All right, that's going to give me 2. Bring down the 1. 3 into 21 is 7. 7 times 3 is 21, and there's no remainder. So if I were to divide 51 in by 3, because that's the pattern that I'm seeing here, that means that I'm going to have 17 sets of these. So there are going to be 17 of those 259s with nothing left over, which means if there's nothing left over, then I land on the last number. So if the remainder is 0, that means that the digit that's 51 placed to the right of the decimal is actually going to be 9. Okay, let's try this trick with another number. So let's say we're looking at the same number, but now I want to see, let me see, let's do 52 places. So now we want to find the 52nd place, 52nd digit. You could put it that way. Okay, I'll leave it like that. So we're going to do the same thing. We're going to divide 52 by 3. Okay, so doing it the long way, 1 times 3 is 3, 2, bring down the 2, 7, 7 times 3 is 21, and that's a remainder of 1. So in this one, since we have a remainder of 1, that means it's going to land in the first spot. And if that doesn't make sense to you, think of it this way. 51, can't get this on the screen. 51 landed on a 9, so the next number should be a 2, which happens to be the first position because there is one remainder. So my digit would be a 2. Put it here, that's better. 2. So with this, we can kind of conjecture that if we divide, okay, so if we divide by the number of repeating digits, in this case 3, okay, we can determine by the remainder, because that's what we're using, remainder, what number the digit will fall on. Okay, so let's try one more example just so you can kind of see what we're doing here. Let's do a kind of an easy one just to make sure this will be our step number 4, reviewing the solution. Okay, see if it works. So let's pick an easy one. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Let's do the 8th term. Okay, because we know it's a 5. So let's see if our method works. So the 8th term. Yeah, scroll because you can see that still. So that means I would take 8 and divide it by 3. Okay, so 8 divided by 3, I know it goes in 2 times. 2 times 3 is 6. 8 minus 6 is 2. So the remainder is 2, which means that it should be the second digits in my repeating numbers, okay? And repeated sequence. So the second number is a 5, and that's exactly what I wanted, a 5, okay? So in this problem, we actually came up with a method to figure this out easier, okay? Now, of course, if this doesn't work for you, let's say this is just too much math or whatever's going on, by all means, you are more than welcome to do this list if you need to, okay? If that makes it easier for you. The idea with this method is that we're trying to find the shortest way possible to solve this, or at least the way that makes sense to us, okay? So I'm going to go ahead and move on to another problem. Not this one quite yet. Let's look at, or actually, yeah, let's do this one first. So for this problem, let's see. We have if 7 people greet each other at a meeting by shaking hands with one another, how many handshakes take place? So let's identify the problem. Do we understand what's going on? I understand that you have these 7 people, they get to this, place and they are just saying hello to each other by shaking hands. And they want to know how many handshakes in total took place if everybody shook hands with each other at least once. Okay, we're assuming they don't shake hands more than once with each other. So that's the problem. I think for a plan for this one, it would be better to just kind of draw a picture. To be honest, I think that'd be the best way because it's only 7 people. It's not that many things that we have. If it was like 100, then yeah, we'd probably have to come up with a better formula for this, but it's only 7 people. So I think I'm just going to draw a picture and go from there. Okay. Let's go ahead and carry out that plan. So let's say I'm going to go ahead and do my 7 people. So there's person one, person two, person three, person four, person five, person six, and person seven. Okay. So one has to shake hands with person two, person three, person four, person five, person six, and person seven, right? So one shook hands with all of these guys already, all right? So that's a total of 7 handshakes. So I'm going to put my totals down here, okay? Two is next. So person two already shook hands with number one. So I don't have to include one again, but they did shake hands with three, with four, five, six, and person seven. So I don't have to put one because again, one and two already happened here. They're not gonna shake their hands twice, otherwise it's a little awkward. Okay. So that's a total of 1, 2, 3, 4, 5, 6 handshakes. Okay. See how it works out? Moving on. Person number 3, well, they already shook hands with 1 and 2, so that means they still have to shake hands with 4, 5, 6, and 7. And that would be a total of 1, 2, 3, 4, 5. 1, 2, hold on. 1, 2, 3, 4. Oh, I'm sorry, I'm off by 1. So that's 4 handshakes, which means this would be 5. That's why it helps to draw a picture. Let me show you what just happened. It's 1, 2, 3, 4, 5, 6. So this is actually 6 handshakes, okay? And this one is 1, 2, 3, 4, 5. So 5 handshakes. Hope I didn't confuse you there. I counted one too many. All right, so now that we're back on track, we're gonna go ahead and you can probably figure out the next ones, but we're gonna continue with the pictures anyway. So number 4, person number 4 had to have shaken hands with 5, person 6, and person 7. They already shook hands with these guys, so I don't have to include them in that list. So let's see, that's 1, 2, 3 handshakes. Okay. Person number 5 already shook hands with all of these guys, so I just have to shake hands with 6 and 7, which is a total of 2 handshakes. Okay. Person number 6 already shook hands with all of these guys, so they just have to shake hands with number 7, which is a total of 1 handshake. And person number 7, at this point, they are done. They shook hands, look, 7's on all of them. They already shook hands with everyone, so there's 0 handshakes left. So if I want to add all these up, total them up, I'm just going to add them up. 6 plus 5, 11, plus 4 is 15, plus 3 is 18, 20, 21. So I have a total of 21 handshakes. Okay, and then to check, I would just make sure that I don't have any doubles. So I can see here that and you can kind of see by the pattern I have here, the sevens are going down 6, 5, 4, 3, 2, 1. 1 shook hands with everyone. Okay. 2 has everybody here as well, except for 1, but 1 already happened here, so I'm good to go there. Number 3 shook hands with everybody else, and 2 and 1 as well, because they're over here. Number 4 shook hands with 5, 6, and 7. And again, 3, 2, and 1 already took place with 4 over here. Same with 5, same with 6, same with 7. So it looks like I'm good to go. Just going to check my math one more time. 2 plus 1 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21. So my answer seems pretty correct. All right, last problem. And this is one I wanna see if you can figure out. This example is one of those that you often associate with as a riddle because they tend to be a bit deceptive. Okay, so this one says that we have two US coins that have a total value of 35 cents. One of the coins is not a quarter. What are the two coins? So let's see if we understand the problem. They want us to find two coins. So remember from coins we have quarters, we have dimes, we have nickels, we have the penny, and we even have, I think we have those 50-cent ones too. Not that that's going to help us, but and the dollar ones. But we don't need those because 35 cents is way less than that. So we have these four to choose from, okay? One of the coins is not a quarter. So of those two coins, one of them is not a quarter. So what are the two coins? That's what I'm understanding. So my plan is to try to combine these four into two out of the four to come up with 35 cents. Now this problem is a little bit deceptive because it's telling us that one of the coins is not a quarter. So I'm going to give you a few seconds to see if you can figure out the answer to this problem. So the answer to this problem is these two coins. Why? Because there's no other combination that's going to give me 35 cents. If I try to put 10 and 5, that's 15, 20, I'm sorry, 10 and 1, that's 11, 5 and 1, that's 6 cents. So there's no way it's going to work. The deceptive part here is that one of the coins is not a quarter. So just because one of them is not a quarter doesn't mean that the other one cannot be a quarter. And therefore, it's a little bit tricky. So, moral of the story, read carefully. And this is something in all my years of teaching that has been a very difficult concept for students to master because you guys don't like to read. So, read carefully, okay? Chances are that if the problem sounds impossible, there is some kind of catch, there's some kind of twist that you're missing in there, okay? I think that's it, guys. I don't yeah, that's about it. Your assignment's gonna have make you think. There's one problem in particular that I'm interested in to seeing how you're gonna solve it. Um, again, this was section 1.3. If you have any questions, please feel free to reach out to me. Thank you.